Yes, my voice is audible. Please check. My voice is audible.
Sir, audible, sir.
Okay, the PPT is also visible.
Yes, sir, visible, sir.
Okay, ma'am. Thank you. So total 50 participants are there. We'll wait another 1 minute, 1 or 2 minutes. Now we'll continue, ma'am. Yeah. Now we'll go the denominator new denominator term. Denominator term get cancelled. 2 see omega square is there. Here also omega square. Omega square also get cancelled. Only you get c square. That is 1 over by c square. You can take numerator is change in that will not change as it is. You can write here. Right. Yes. After this, now send this c square to the left side. Now what you will get? Send this c square to the left. You will get c square is equal to this right hand side. The term will not change as it is, and at the same time, now we'll go for split this one. This term mg plus e into 1 plus k. Send this mg into 1 plus mg into k, or else take mg into 1 plus k plus e into 1 plus k. Now split this term. Next. Now what you will get? Now see this in this equation. See that in the denominator term is 2 times of mg plus capital Mg plus 1 plus k. In the numerator term also it is 2 times of mg plus mg into 1 plus k plus e into 1 plus k is there. Not in the numerator take the common 2 times of mg plus mg into 1 plus k. Take this as outside here. Once you take this term outside, only this term, take outside in the numerator, what you will get? You will get 1 plus e into 1 plus k whole divided by this term will get, right? Yeah, that you can see in the next slide. Now you can see here. Now once you take 2 times of small mg plus capital Mg terms of 1 plus k, take outside in the numerator. Now we'll get 1 plus, I think it is visible. 1
Yes, sir.
e times of 1 plus k divided by 2 times of mg plus mg into 1 plus k. Now you can see the numerator and denominator, these two get cancelled. Once these two get cancelled, finally you will get again. Now send this one to the left side, and our aim is to determine what? Effort only, right? Send the 1 to the left side, it becomes c square minus 1. Then send this also to the left side, it becomes divided by 1 plus k. And then send this also left side. Only our aim is to determine what? Effort. Now finally E is equal to c square minus 1 divided by 1 plus times of terms of 2 times of mg plus capital Mg into 1 plus k. Now this will be the what? Effort of the governor, right? This will be the effort of the governor, or you can rearrange this term, rearrange the term. That is how you rearrange the term here. Actually effort, this is the total effort it is, but I need only the effort occurred only the one side, on the left side or on the right side. Then what we will do? Again we will take a 2 is it take 2 from outside from the bracket. Once you take 2 outside from the bracket, you get 2 times of c square minus 1 divided by 1 plus k. What is the inside here? Mg plus, once you take 2 outside here, it will become mg divided by 2 will get, right? Mg divided by 2, 1 plus k. Now again send this 2 to the left side. What is the effort? Effort is nothing but E by 2. Why do you consider E by 2? On one side, one governor bulb, how much effort is required? On another side E by 2, one in another side E by 2. Total E by 2 plus E by 2, total it is, total effort on the sleeve it is E, right? That's why I'll take effort is always you take E by 2. E by 2 is equal to, this is the equation you should remember. E is equal to, sorry, effort is equal to E by 2, that is equal to C square minus 1 whole divided by 1 plus K, inside the bracket small mg plus capital MG divided by 2 1 plus K. If you consider a friction, just you go for plus or minus in that mg is there now. Just change here mg, it is equal to what? Capital Mg plus or minus F you take. If you consider friction, then you go for change only mg is equal to mg plus or minus F. Clear? This is the effort is required to move the sleeve upward or downward. That is, C is nothing but what? Is amount of increase in speed. Amount of increase in speed from omega to C times of omega. Now once we calculate effort, what is the next we required? First we determine height of the governor, next speed of the governor, next effort of the governor. After effort, what is the next one? See the in the basic concepts. In the basic concept, first one is controlling force, second one is, what is second one? Sensitiveness. Third one, what is the third one? Sensitiveness. After the sensitiveness, you can see the stable, unstable, sorry, isochronism. Next, effort of the governor. Next, power of the governor. Next one, I want to determine power of the governor. Now, how do you determine power of the governor? Means amount of work done by the porter governor. When sleeve moves upward, there is a change in position of the sleeve. How the position of sleeve takes place? Due to an effort is required, force is required to move the sleeve. Whenever force into displacement is there, there you can get the work done. See the power of the governor. For a porter governor having all equal arms which intersect on the axis or pivot at the point equidistant from the spindle axis. Now power of the governor is, what is the general formula for power or work done by the governor? It is effort into sleeve lift. What is the effort? We calculate effort is E by 2. What is the sleeve lift? Sleeve lift is nothing but, you can see this. 1 minute. Yeah, you can see this. What is the sleeve movement? Sleeve movement is, the sleeve has to move from, okay, 1 minute. Sleeve has to move from this is the position, equilibrium position. Now from this position it is what? This distance is A, right? Or that is also called as, we take that as a H. Now sleeve movement here, this is a sleeve movement. The sleeve movement is equal to, is a 2 times of change in height of the governor. Why do you take change in height of the governor? Means if you increase the speed, the point A is the governor ball masses move from A to A1, right? A to A1. Now this is a, for example, called as, this is a B to B1. Now take, this is the sleeve movement. This is the lift. Okay, sleeve lift. What's the total sleeve lift here? Now this is a sleeve movement is, this is the height of the governor. At the same time here also height of the governor is there from change in position, right? On both sides you consider here, that's why 2 will multiply here. The sleeve lift is a 2 times of, this is a H1, sorry, yeah, this is a H1, this is the height of the governor is H1, H1 minus H, that gives this height, but I need total lift here, that is a 2 times of this height will be the sleeve lift. That's why we multiply 2. Why do you multiply 2 here? You will consider only the height of the governor from the governor ball position here. The upper position you consider sleeve lift. Sorry, governor height. At the same time, bottom also the movement of the sleeve is there. Bottom also the lever moves upward. That height I also consider. This is the one side. Sorry, this is the one side. This is the another side. This is the 2 times you multiply here. There is a 2 times of change of height of the governor. Now remember this formula. Power is equal to effort into sleeve lift. Effort is nothing but E by 2. Sleeve lift means nothing but twice of change of height of governor. Height of governor already we determined, right? Twice of height of change of height of governor. Yes. Any doubt regarding this? Yes, please ask the question. If you're not able to understand it, please ask the question.
Sir, once more, sir.
The sleeve lift you want? Yeah, see the sleeve lift is nothing but 2 times of change in height of the governor. So what is the change in height of the governor? What is the height of the governor? If it is in equilibrium position, this is the height of the governor, h. Once the speed increases, the ball moves radially outward. Now it takes another position that is called as A1. We'll take A1. Now, now we'll draw this. This is the upper arm position, and somewhere it is the lower arm position. Now this height is called as a, this is also called as height of the governor at when speed is increased, that is called h1. Now what is this portion here? What is this difference it is? h1, so h minus h1. This is the h minus h1. Now I can write here better. Now what is this distance here? h minus h1. Now we'll consider only that height of the governor in above the governor ball rotates. Below also see that. Below also the sleeve, whatever the leaves moves upward, the sleeve moves upward here. But I need what will be the total height here? B to B1. This is the high sleeve lift. This is the lift. This is the sleeve lift here. Now sleeve lift is always twice of the change in height of the governor. Yes. Here on one side is h minus h1. Another side also if you consider, now if you consider this is a h. For example, this is a h. Again the ball moves here. Now this is called as, not h it is, actually it is h2 it is called as. Now this is a sleeve lift, h minus h2. That h minus h2 is what here? Twice of h minus h1 it is. Don't make it confuse here. Better you go for make it sleeve lift. Is lift of the is nothing but is a, what is the sleeve lift? It is a twice of height of the governor, change in height of the governor. First you determine h for equilibrium speed. Then when you go for increase the speed for r equal to r1, then h become h1. Then see that what will be the change in height. Then just multiply 2, you will get the height of the governor. Okay. The height sleeve lift is nothing but 2 times of h minus h1. Okay. Now we'll go for take a notebook, pen, pencil, calculator. We'll go for solve the problem on photo governor. Yes. Take 2 minutes time. Take notebook, pen, pencil, eraser, and calculator. Now read the problem. Once or twice. Now he given in a photo governor. First identify type of governor. What is the type of governor? It is photo governor. In a photo governor, each of the 4 arms is 400 mm long. So whenever the type of governor is given, first you write the sketch for the governor also. One minute. Yes. See the in a photo governor, first identify type of governor it is. It is a photo governor. Immediately you write the sketch for the photo governor. Right? Each of the 4 arms is 400 mm long. Means length of the arm is given. OA, AB, CD, OD. That length of the arm is given. All the length of the arms are equal in length. That is how much? 400 mm long. The upper arms are pivoted on the axis of the sleeve. Upper arms are pivoted on the axis of the sleeve. What are the upper arm? OA and OD are the upper arm that is connected to the axis of the sleeve or axis of the governor shaft. That point, pivoted point is called as O. The upper arms are pivoted on the axis of the sleeve, whereas the lower arms are attached to the sleeve at a distance of 45 mm from the axis. Now see, the lower arms are not connected to the directly to the governor shaft axis. It is at a distance of 45 mm from the governor's axis. That is what is a BG or GC. This distance is given. This distance is how much? 45 mm from the axis of the governor shaft axis. This is a 45 mm. This distance is BG or GC. Any one side you can take 45 mm. Each ball has a mass of 8 kg. The mass of the small m is given. First, the type of governor is porta governor is given. Next, each of the four arms, the length of the arm is given, L is given, 400 mm long. The upper arms are pivoted on the axis of the sleeve, whereas lower arms are attached to the sleeve at a distance of how much? 45 mm from the axis. That is the distance between BG is given, 45 mm. Each ball has a 8 kg. That is the mass of the governor ball. Small m is given. And the load on the sleeve. The load on the sleeve, be careful about unit, 60 kg. This is a what symbol it is? Kg is given. This is capital M. This is small m. Okay. Now what will be the equilibrium speeds of the two extreme radii? First extreme radii is take r is equal to ri, 250 mm. Second one, take r is equal to r2, that is 300 mm. Or take r is equal to, for first speed, take r is equal to 250 mm. Second one r is equal to 300 mm. The rotation of the governor. Our aim is to determine what will be the equilibrium speeds. Equilibrium speed means what we are going to determine? N you are going to determine. This is our aim. Yes, read the problem once or twice. Now write the given data and write the corresponding the diagram. Yes. Any doubt regarding this? What are the data given? Is given the type of governor is, once read the problem once or twice, write the appropriate sketch for the porta governor, then write the given data. It's a porta governor is given, 4 arms, the length of the arm is given, L is given. Next, the upper arms are pivoted on the axis, whereas lower arms are attached to the sleeve at a distance of 45 mm. That is distance between BG is given 45 mm. Now each ball has a mass, small m is given 8 kg, and load on the sleeve, that is capital M is given. What will be the equilibrium speed? Now I want to calculate what will be the equilibrium speed. N I want to calculate. If the two extreme position, one extreme position when R rotates, R is equal to 250 mm. 250 mm. Another one R is equal to what? 300 mm. So I want to calculate N. So whatever the dimensions are there, now convert the dimension millimeter into meter. Force should be in Newton. Mass should be in kg. Over. Up to this step over. Yes, please give me response. Is any doubt regarding this? If you
The
have,
voice is breaking.
please unmute yourself and ask me the doubt. Your internet connection is unstable. Yes, my voice is audible. Yes, please respond me.
Yes, sir. Audible, sir.
Audible. After this over, you have read the question once or twice. You have taken the sketch, and also you have written the given data and unit conversion. So if you say yes, then I'll move on to the next slide. Shall I move on to the next slide? So give me response.
No, sir.
Yes, shall I move on to the next slide? Yes, give me response.
Just a minute, sir.
Okay, just a minute. Just give me response. Until that, I will take attendance. Kumar, US number 34.
Sir, figure ಸ್ವಲ್ಪ zoom ಮಾಡಿ.
Trouble me. Trouble in the class, in the meeting, man. Is Girish Kumar, US number 34.
Sir, figure ಸ್ವಲ್ಪ zoom ಮಾಡಿ, sir.
Okay. A figure, you only write the figure, man. The sketch you should write. Is a photo governor, you write the sketch. Yes, now it's visible. Yes, give me response.
Yes, sir, visible, sir.
Those who finished, now I'll move on to the next slide. If you say yes or no. Shall I move to the next slide?
Yes, sir.
Okay. Now read the problem once or twice, write the appropriate sketch, then write the given data. See that? Yeah, this is the given data. All link lengths are same, converted into meter. Mass is given, small mass of the governor ball is given, small m. Mass of the sleeve is given, capital M is given, 60 kg. The distance between BG is 45 mm. I want to determine equilibrium speed when R is equal to 250 mm and another one is R is equal to 300 mm. Right? Now, first, if you want to determine speed, first I want to know the height of the governor. Now, is there any friction in the problem? Is there any statement is given? Consider a frictional force or not? Yes? Now, in general, the height of the product governor is H is equal to G by omega square. Yes, missing here, omega square plus capital Mg plus or minus F into 1 plus K divided by 2 times M omega square. This approach is very, very important. If you want to calculate speed, I should know the height of the governor. Right? No, it is omega square, it is, make it correction. Yeah, this is G by omega square plus Mg, capital Mg plus or minus F, 1 plus K divided by 2 times of M omega square. Called as equation number 1. Now, in the problem, the statement is given, consider frictional force. If the frictional force, the value is given, then only consider the frictional force. So much of Newton. But here the F value is not given, put F is equal to 0. What is G? G is nothing but 9.81 meter per second square. Now, K is also unknown. Here I want to determine omega square is the unknown. First I want to determine omega square. If I want to determine omega square, first I want to determine H value, H is unknown, and also K also unknown. K is what? It's the ratio of tan beta by tan alpha. Again, how to calculate tan beta? Then how to calculate tan alpha? Now see this sketch. I think the sketch is visible. Just give me response.
Visible, sir.
Yeah. Now how to determine tan beta? So how to determine tan beta? Now see this. Now consider 1 minute. Consider this right angle triangle. Consider this right angle triangle, that is BJA or ABJ. ABJ is a right angle triangle. The angle of B is beta, right? So I know this L2, I know that L1 is equal to L2 is equal to L3 is equal to L4. That is 400. This is a 0.4 meter. I know that. I don't know AJ and I don't know JB also. Now, how to easily calculate AJ value? What is AJ? AJ you can easily calculate. See that. From A to H, how much? A to H is R. That is how much is given for first case. Take case number 1. R is equal to 250 mm. AH is nothing but 250 mm. At the same time, JH is equal to BG. That is 45 mm. Now what is AJ? 250 minus 45. AJ value is how
205.
much? Sorry. AJ value is how much you got? It's not understood.
205.
205, right, ma? AJ value you got 205. Yes, AJ value got 205 mm. Once you got 205 mm AJ value, L2 is 400. Then how do you calculate BJ value? How do you calculate BJ? Now what type of triangle it is? Yes, please respond me, otherwise if I keep on telling that you're not able to understand. How do you determine BJ value? When AB value you know, AB is 0.4 mm, AJ is 205 mm means 0.205 mm, sorry 0.205 meter, right? 0.205 meter, make it to 1 unit, 0.025 meter. Next, how do you calculate BJ? What type of triangle it is?
Pythagoras
Right
theorem.
angle triangle. By applying this
Pythagoras
theorem.
theorem.
Yes,
Pythagoras theorem.
yeah, Pythagoras theorem. Good. By applying Pythagoras theorem, that is what the Pythagoras theorem says, that the square of hypotenuse side is equal to the sum of square of two adjacent side. That is AB square is equal to BJ square plus AJ square. Then you calculate BJ value. See that? That is what we follow step here. Now first you consider R is equal to 250 mm, that is 0.25 meter. In that, by applying a Pythagoras theorem, right? By applying Pythagoras theorem, now first here you calculate alpha value. Okay, no problem. Okay, first you calculate. Sorry. Yeah, first you calculate tan beta. For how to calculate tan beta? See that by considering right angle triangle ABJ, AB square is equal to BJ square plus JA square. Now AB is 0.4. That is a L2 link. 0.4. BJ is unknown. Again, JA is nothing but AH minus HA. That you calculated, you will get 0.205. Now substitute. Now check the value. BJ value is how much? How much you got BJ value? Is it right? Check. Yes, still only 10 minutes time is there. Better you finish within that time only. As BJ value check, you'll get same value 0.343 meter. Please give me response.
Yes, sir. Calculating.
Has anybody got the same value? Bj is equal to yes, Bj is equal to how much you got? Yes, please do the calculation. Take case number 1 when r is equal to 250 mm means 0.25 meter. First you calculate Bj means tan alpha. Once you calculate Bj, then you can easily calculate tan beta. How do you get tan beta? Tan beta is equal to opposite by adjacent. Opposite side is nothing but Aj. Adjacent is nothing but Bj. That's why you calculate Bj value. Yes, anybody got the value Bj?
0.34.
0 point S
0.34, sir.
0.343 meter, right? Then you go for calculate tan beta. Tan beta is equal to opposite side by adjacent side. Opposite side nothing but Aj, adjacent side nothing but Bj. Then calculate, then substitute, then you'll get tan beta value. You'll get in terms of what? In terms of degree, right? Am I right?
Yes, sir.
Yeah.
Yes, sir.
Next, I want to calculate tan beta over. Next, I want to calculate tan alpha. How do you calculate tan alpha? Again, use the same figure. See the photogovernor. Again, OAH. In the triangle, right angle triangle, OAH. See that OA, that is nothing but L1. That is 400 mm, means 0.4 meter. Then OH, we know that height I don't know. Then how to calculate H? Again we go for apply OAH is a right angle triangle. Again you go for apply a Pythagoras theorem. That is OA square is equal to AH square plus HO square. In that OA is nothing but 0.4 meter. AH is nothing but what? R. R is equal to, for first case, 250 mm means 0.25 meter. Then you calculate H value. Now tell me what is the H value you got? See that. From the considered right angle triangle OAH, apply the Pythagoras theorem for the right angle triangle OAH. Then we'll get H value. Check H value, you got 0.312 meter. So you write the formula, then go for substitution, then go for calculation, then check the answer, whether it is right or wrong. Yes? And those who are calculating, once you finish your
Yes, sir.
calculation, now unmute yourself, then tell me the answer. Yes, H value got same 0.312 meter.
Yes, sir.
Yeah, once you got H value,
Yes, sir.
how to calculate tan alpha? What is tan alpha is equal to? Opposite divided by adjacent side. What is opposite side for this triangle, right angle triangle? OAH. Opposite side is AH. AH is nothing but what? R, 0.25 meter. H is nothing but, just now we calculated 0.312 meter. Now we calculate tan alpha. What is tan alpha you got? Check tan alpha you got 0.801. Not is actually not in degree, it is in radian actually. Yeah, tan alpha is not radian also. It is a value. Tan alpha you got 0.801. Is it right? Yes, please do the calculation, write the formula, substitution, then do the calculation, then tell me the answer. Yes? Is it right? Tan alpha is 0.801. Then go for k value. What is the k? Tan beta by tan alpha. Then we'll get k is a constant, that is 0.747. Right? If you say up to this is finished means, then we'll move to the next slide. So how do you approach the problem? First read the problem once or twice. First identify type of governor, then write the sketch for the type of governor, then take the given data and convert it into units, then apply this formula. For photo governor, H is equal to G divided by omega square plus mg plus or minus f into 1 plus k whole divided by 2 times of m omega square. Apply this formula. In this, take case number 1. When r is equal to r1, the r is equal to 250 mm means 0.25 meter, then calculate. In this formula, I want to calculate omega. How to calculate omega? First, I should know h value, then I should know k value. Then see that first determine h value. Already in the while calculation we determine h value and also we determine k value. Then back substitute to this equation. Once you substitute that equation, now we'll get omega square. Am I right? Substitute the values, above values into the equation 1. H is 0.312, G 9.81 divided by omega square plus capital M is 60 into G 9.81 plus or minus F value is not given. Frictional force is not given. Take that as 0. 1 plus K you calculated 0.747 divided by 2 M. Small m is 8 kg omega square. Then take omega square common. Then you get the omega is equal to how much? 15.408 radian per second. Now convert into speed. Omega is equal to what? 2 pi n by 60. Now we'll get n is equal to, now you calculate and tell me the value. Check value 147.18 RPM will get. Is it right? Still 1 minute time is there. I'll take the attendance. At the same time, those who completed, please tell me the answer.
147.13.
Sorry?
147.13.
Yeah, 147.13 RPM. Good. Similarly, this is the first. You consider R is equal to 250 mm. Similarly, go ahead. When R is equal to 300 mm, 0.3 meter. Same procedure. Follow the same procedure and tell me the answer. Okay? Yes. Until that, I'll take the attendance. Only 1 minute is there. Okay. Participants. Better I'll take this print screen. So once the session is ended, okay, again don't rejoin the session. Okay, not take the print screen.